Okay, so now we're recording. Okay to clear? Yep. Okay to clear. So let's do these two examples here. I think these are pretty simple to work out. So baseball, that mass with initial velocity of negative 40 meters per second to 9 miles per hour. And it's hit, so it's coming at you, right? So it's going towards, so you kind of consider it to be a negative velocity. And then, of course, you hit the ball, and it goes the other direction, right? So remember, velocity always has direction involved. So you hit the ball, the ball leaves the bat with velocity 6 meters per second. So usually it's going to be faster. And it's a collision, right? You're dealing with a collision. The bat's colliding with the ball. Usually if it's a perfect collision, you tend to expect the speed to double. But that's another situation we'll talk about later. But the time of contact is very, very little, 0.001 seconds. So the impulse and average net force applied to the ball by the bat. Okay. So our impulse is the change in velocity. So we'll use this formula, F times delta T. That's impulse. Also, it's this as well. So impulse can be measured in both kind of fashions. So in order to calculate the impulse, and we can call it like I or J, I don't really care what letter you use. Let's use the letter I for impulse. So it's going to be your mass times your final velocity times your initial velocity. And we tend to give the units as a Newton times second. Or you can use kilograms. That's the standard unit for impulse or momentum. So yeah, we just plug in your calculator, work it out, and you should get 14 as the answer. So that's the impulse that we notice. Then the force, your impulse is this. So 14 equals your force times 0.001 seconds. And hold on a sec, I don't know why here's doing that. And it should be about 14,000 newtons, so it's quite a lot of force that a ball experiences. So it's, you got to be really careful when you're fielding a ball like that. Those comebackers that pitchers sometimes have to avoid can be very dangerous too. So that's all you're doing for that one. Any questions? Nolan, you had a question or no? You're okay?
I was going to tell you that your screen was like frozen.
Oh, that could be because can you see my screen now?
It's still kind of frozen.
Let me do this. Let me get on my hotspot. Okay, how are we now? Are we okay? We're good? Okay, we'll keep moving. Let's take a look at the next one. A raindrop with that mass hits a roof of a car at that speed, that velocity. After it hits, so it's going down, so you can start being negative. After it spatters, after it hits, it spatters, so the effective final velocity is 0, okay? The time of impact is 0.1 seconds. What is the average force? And then they're asking, what if it is ice, so it bounces off at 10 meters? So there's a bounce off the car. We'll worry about the second part later. But for now, what is the average force? So you're going to do this. Force times delta T equals mvf minus mvi. So your force times 0.01 seconds. Mass is 0.001 times the final velocity, which of course is 0, minus 0.001 times negative 15. So force times 0.001 equals, let's see here, 0.001 times 15. So negative, so positive 0.015. So force divided by 0.001 should be about 15 newtons. So it's not so bad when a raindrop hits you, right? You feel it, but it's not as bad as being hit by a baseball. So being hit by a baseball would hurt a lot. So any questions about that one? We're okay? Okay, good. Then you're being asked, what if it is ice so it bounces off at 10 meters per second? So you're just going to kind of redo the problem.
Wait, Mr. E?
Yeah, can you hear me?
Yeah,
Okay.
Isn't the time 100th of a second?
Yeah, you're right. You're so good at catching my mistakes. So actually it's 1.5 newtons.
And is it kg, 1.5 kg?
No, because we're solving for force.
Oh, okay.
Yeah, so if we actually look at the units, time is in seconds, and MV. Remember, MV is going to be kilograms times meters per second, and then when you divide that time, you're dividing by seconds. So it comes out, which is mass times acceleration, which is a Newton. Okay, so now we just do this one more time. Force times 0.01 equals your mass, which is 0.001, times 10 now, because it bounces off, minus 0.001 times negative 15. If you work that out correctly, you should have 0.01 minus, or becomes positive, 0.015, I think. 1, 2, 3. So you get 0.025. So your force is going to be 0.025 divided by 0.01. And so in this case, now we get 2.5 newtons. So that should be hopefully pretty straightforward for that one. So any questions about that one? Okay, so we're not quite doing conservation momentum today. That'll be tomorrow. And there'll be a bunch of videos. Actually, I just uploaded Schoology, the new videos. I still got to create the Google form. I'm about to do that. I'll probably do that during your next breakout session. So let's look at the problems that you guys work on now. And we can come back to these conceptual problems just a little bit. Maybe we'll do 7 through 10. They're very similar to what we just did. So they shouldn't be too bad. So I'll have you guys do 7, 8, 9, 10. We'll do that in about 10 minutes or so. Then we'll come back and do some of the conceptual questions. And then we'll probably do some leftover questions tomorrow for sure. And then we'll obviously do some more problem sets tomorrow. But yeah, let's do 7, 8, 9, 10 over 10 minutes. So stop sharing. Breakout rooms. Let's actually put 3 people per room now. There we go. 10 minutes. And you guys will go. So again, you're doing 7, 8, 9, 10 of 3, 6.